Hi guys. So today we're going to look at the concept of a percentile. Like if you go to the doctor and they tell you your height is at the 95th percentile, the word percentile is not exactly a percent. It tells you the number, it tells you what percent is at or below a particular value. What percent of the total number lies at or below a given value. So let's say this example represented scores on a test, which are really bad scores. And let's say you got a 69. So instead of telling your parents you got a 69, you could say, well, you did equal to or better than, let's say, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You did equal to or better than 15 kids in the class. And there are only 20 kids in the class. So you did equal to or better than 15 kids in the class out of 20 kids. So it's actually not a bad score, Mom and Dad. So the percentile, now you convert that to a percent. So if you convert that into a percent, you multiply by 5, you're going to get, you're at the 75th percentile. So you count how many were equal to or better than, and then you put that over the total and convert that to a percent. So that's what 75th percentile means. It means that a score of 69 is equal to or better than 75% of the class. That's what that means. And when you think about quartiles, when we looked at the box and whisker plot yesterday, quartiles, the 75th percentile is really the third quartile. Because remember, box and whisker plot looks like this. This value here is the third quartile, and it divides 75% of scores are below that. Okay, so the first quartile, going to here, the first quartile is really the 25th percentile because 25% of scores are below that. And the median, or the second quartile, is the 50th percentile. Okay, moving on, we're going to look at also the idea of cumulative frequency. So a cumulative frequency table basically adds the frequencies that came before it. So if you look at this table, how many kids scored between 51 and 60 on a test? 20. So I'm going to put a 20 here. But then 40 kids scored between 61 and 70. So the next in cumulative frequency, in the next row, you would put in 60. You would add the 40 plus the 20 kids that came before it. This represents the number of kids who got a 70 or below. And then the next row is going to be the number of kids who got, if 75 kids got from 71% to 80%, you add the 75 on to the 60, 135 kids got a score of 80 or below. And then in the next row, you're going to add the 60 to the 135. 195 kids got a score of 90 or below. And then the last one is where you add the 45 onto the 195, which is going to give us 240. These are the kids who got 100 or below. Now, if you got 100 or below, that's basically everyone who took the test. This is everyone who took the test. That represents your total frequency. When you graph a cumulative frequency table, you only graph this column, and so your bars keep getting taller and taller and taller. So, and you'll notice the intervals down at the bottom. So the first bar is everyone who scored from 51 to 60. Then the next bar is everyone who scored from 51 to 70, and then 51 to 80, and then 51 to 90, and then 51 to 100. So the tallest bar represents the total frequency, everyone who took the test. When you are graphing, like over here, this, you could tell it's a cumulative frequency histogram, because the bars keep getting higher and higher and higher, and the intervals all start with the same value because they're growing. It's like who got below 59, then who got below 64, who got below 69. Now, what they're going to ask you are some questions about, like, where you have to interpret between the intervals. So part A says, how many scored between 64 and 69? And if you look at the table, at the graph, there's no bar that goes from 64 to 69. So what you have to do is you have to look and say, okay, well, this bar here in purple goes from 55 to 64. And then the bar in green goes from 55 to 69. So 64 to 69 is the missing piece in between. That it's basically like you're adding on to from one bar to the next, because it's cumulative. They keep adding more and more. So you have to figure out what that yellow section represents, and you subtract. The top of the yellow is 15 and the bottom is at 8, and so that yellow bar represents 7 people. So when you read these, it's like from the first bar is 2 people scored from 55 to 69. And then the next bar is like the 2 people are still there, but then there were more people added on who got from 59 to 64. So it starts at 2 and ends at 8. So there were 6 people. And then the next bar is the previous bar inside of it. It's these 8 people who scored from 55 to 64, but then more people got added on top, and those people are the people who scored from 64 to 69. And that starts at 8 and ends at 15, so that's 7 people. And then the next bar contains the previous bar in it, so it goes to here, which is 15 people, but then more people got added on top, and they scored from 69 to 74, from this number to this number. So that's going to be from 15 to 19, which is 4 people. And then the next bar contains the previous bar in it, which is 19 people, but then it added on another person on top, or 2 people, or 1 person scored from 74 to 79. So when they ask how many students scored between 59 and 64, let me erase all this. Oh, that's not eraser. No, it's not letting me erase now. There we go. So in part B, they're asking you how many students scored between 59 and 64. So 59 ends here and 64 ends here. They're asking you, what is this part that got added on from the first bar to the next one? So this goes from 2 to 8. So I'm subtracting 8 minus 2. This represents 6 kids. How many students scored higher than 69 on part C? So higher than 69 is just everybody who's above this bar, because this bar goes to 55 to 69. So they're asking you how many kids from here to the top, because the last bar is the top. So that missing piece, I'm just transferring it over to here, is from 15 to 20. So 20 minus 15, there are 5 kids who scored higher than 69. Part D, which 5-point interval contains the median? So this one's kind of a little bit tougher. The 5-point interval that contains the median, let me erase this, is asking you, when they say 5-point interval, they're saying like not 55 to 64. That's not 5 numbers. That's not 5 points. 5-point interval is 55 to 59, the first one, or it could be, I'm looking at the numbers here, 59 to 64, or from 64 to 69. These represent 5 numbers at a time, 5-point interval, or 69 to 74, or 74 to 79. It's the 5 scores that each new bar adds on. So one of those 5-point intervals, which 5-point interval contains the median? So now you have to think about what we did yesterday. To get a median, you need to know the middle person. Which is the middle person? Well, I look first at my tallest bar. The tallest bar tells me that there are 20 people. So if I have 20 people and I divided them into equal sections, I'd have 10 people on one side and 10 people on the other. So the median is the last person in this group, which is the 10th person, and the average of the next person in the next group, which is the 11th person. So I'm looking to see where the 10th and 11th people are. Well, so I go to the bar that contains 10 and 11 in it. The bar that contains 10 and 11 in it is this one here. It's the but it's not 55 to 69 because that's not a 5-point interval. The 5-point interval is which 5-point interval represents that section that got added on from the last interval to this one. So this represents from 64 to 69. So the person who is in the middle, the 10th and 11th people really, scored between 64 and 69 because that's where the 10th and 11th people are. They're in this 5-point interval that's in green. Okay, kind of tricky. I'm not going to talk too much about this distribution of data. If you graph everybody's scores, they end up creating a pattern really. Like sometimes you have scores more spread out on the left, sometimes you have scores more spread out on the right, sometimes they're all jumbled up. Ideally, you want what's called a bell curve or a normal distribution, which you may have heard of. It's when your scores do this. When you have symmetry, you have 50% of scores on the left, 50% of scores on the right, and ideally the mean and the median and the mode are all equal to each other. And so when you give a test, ideally you want it to be normally distributed. You want to have very few scores at the very top, like A pluses should be very few, the D's or really low scores should be very few, and you should have most scores in the middle. So we would say that things that follow this pattern are normally distributed. In the world, in nature, you'll see that they tend to be normally distributed. So if you roll dice, this is what this image is showing you. If you roll dice, 2 dice, you'll see that very few times you get 2 6s, very few times you get 2 1s, but the distribution ends up being like this, where 7 is the most common, and then from there it decreases on each side. Blood pressure, heights and weights of people, test scores, annual rainfall. If you measure these for large numbers of people or instances, you'll find that they also follow that pattern, that they are normally distributed. And then if it's not normally distributed, then we call it skewed. So this is a right skew, where your tail, we say the tail is on the right, and then a left skew is where the tail is on the left. But again, ideally, we want everything to be normally distributed. Not much of a focus on this on your homework. The focus is really on this, looking at these cumulative frequency histograms. All right, let me know if you guys have questions. Thanks.